Hello students, welcome to this lecture on areas related to circles. Okay, so in this lecture we will discuss areas related to circle. So first of all we will discuss areas of sector and segment of a circle. Okay, so here two words come, areas of sector and segment of a circle. Okay, so here we will discuss first of all what is areas of sector. Okay, and then what is the area of segment of a circle. So what do you mean sector of a circle? Do you know, student? And what do you mean segment of a circle? Do you know? So basically you have studied in your class 9 about sector of a circle and segment of a circle. Okay, so you have already come across the terms sector and segment of a circle in your earlier classes. Okay, in your class 9. And if you recall that the portion or part of the circular region enclosed by two radii and the corresponding arc is called a sector of the circle, and the portion or part of the circular region enclosed by a chord and the corresponding arc is called a segment of a circle. Okay, so student, what is sector of the circle? So sector of the circle is nothing but the portion or part of the circular region enclosed by two radii and the corresponding arc. Okay, and the segment of a segment of the circle is nothing but the portion or part of the circular region enclosed between a chord and the corresponding arc. Okay, so sector of the circle is basically enclosed by two radii and corresponding arc, and segment of the circle enclosed between a chord and the corresponding arc. Okay, so you should keep on your mind these two difference. Okay, so sector of the circle is basically enclosed by two radii and the corresponding arc, and the segment of the circle is enclosed by a chord and the corresponding arc. Okay, so you can now visualize by this figure. So in this figure here, OAPB, this is nothing but a sector of the circle. Okay, so this is the sector of the circle. So here this is enclosed by two radii and by one arc, corresponding arc. Okay, so this is actually a sector of the circle. So now sector of the circle, there are two types of sector of the circle. So first one is minor sector and second one is major sector. So now questions come what actually mean by minor sector and what actually mean by major sector. Okay, so you can easily observe from this figure here, this portion OAPB is basically called a minor sector. Okay, and this portion that is not shaded. Okay, so shaded portion is called minor sector, and not shaded region, that this is called major sector. Okay, so that's in figure 11.1. so this is our figure 11.1, and here shaded region OAPB is a sector of the circle with center O, and here this angle OAOB, this angle is called the angle of the sector. Okay, so this angle is called angle of the sector. So this is angle of the sector, so this is called angle of the sector. And here note it down in this figure, unshaded region OAQB, this is also a sector of the circle, and for obvious reasons here this sector OAPB is called the minor sector, and here OAQB AQB, this sector is called the major sector. Okay, minor means smaller. Okay, small, and major means bigger. Okay, so this sector is small in size. Okay, with respect to this sector. Okay, so obviously this sector is called minor sector, and this sector OAQB, this is called major sector. Okay, so now you can also see that here this angle is called angle of the sector, and now what is the angle of the major sector? So we know this total interior angle of the circles, that is 360 degree, that we know already. Okay, so now if we subtract 360 degree to if we subtract theta to 360 degree, that is this angle, if we subtract this angle from 360 degree, then you will get the angle of the major sector. Okay, so here the angle of the major sector is basically 360 degree minus angle AOB. Okay, so that is the angle of the major sector is basically 360 degree minus angle of the minor sector, that is angle AOB. Okay, so now look at this figure 11.2. so here in this figure, this is actually called segment. Okay, this is one segment and this is another segment of this circle. So we have studied what is segment of the circle. Okay, so segment of the circle enclosed between chord and corresponding arc. Okay, so this is called segment of the circle. So as similar sector of the circle, there are two types of segment of the circle. Okay, so there are two types of segment of the circle. One is minor segment and another is major segment. Okay, so here you can look at this figure. So in which AB, this is chord of the circle with center O, and so this sided region APB, this is segment of the circle. And you can also note that unsided region AQB, this is another segment of the circle. Okay, formed by the chord AB. So for obvious reasons, here this segment of the circle APB is called the minor segment. Okay, and this segment of the circle AQB, this is called major segment. Okay, so APB, this segment is called minor segment. AQB, this segment is called major segment. Okay, and why are they called as minor or major? So it is obvious reasons, since APB, this is smaller segment than this segment. Okay, so that is why this segment APB is minor segment, and this segment AQB, this is major segment. Okay, so till now we have studied sector of the circle, and there we have studied two types of sector, minor sector and major sector. Okay, and then we have studied segment of the circle, and we have studied there are two types of segment of the circle. One is minor segment and another is major segment. Okay, and we also have studied by using diagram. Okay, so I hope this is clear to you. So now we can move to remark. So in this remark, it's said to us, when we write segment and sector, we will mean the minor segment and the minor sector respectively. Okay, unless stated otherwise. So note it down, segment or sector, we will mean the minor segment or minor sector. Okay, so segment, this is mean minor segment. Sector, this is mean this means minor sector. Okay, so now with this knowledge, let us try to some relations or formula to calculate their areas. Okay, so now we will discuss areas of sector and segment of a circle. Okay, so now we will explore some relations and formula to calculate their areas. Okay, so let us start. So here we let here OAPB be a sector of the circle with center O and radius R. Okay, so you can see this figure 11.3. So in this figure, this shaded region is actually sector of the circle. Okay, sector of the circle with center O and radius R. And we also let the degree of angle AOB be theta. Okay, so we here let this angle be theta, and we know that the area of the circle that is in fact of the circular region or disc, that is phi r square. Okay, so we all know about the area of the circle, that is actually phi r square, that you have studied in your previous classes. Okay, so I think you know about this. So what is the area of the circle, that you know, that is actually phi r square. And we also know, or in generally we take the value of phi is equal to 22/7. Okay, so this is actually approximate value, this is not exact value of phi. Okay, so area of a circle is phi r square. Now in a way we can consider the circular region to be a sector forming an angle of 360 degree. Okay, that is the degree of measure 360 at the center O. Now by applying unitary method, so we can arrive at the area of the sector OAB as follows. So now we actually want to form a formula for finding areas of the sector and segment of the sector. Okay, so when degree measure of that angle at the center is 360 degree, then area of the sector is equal to phi r square. Okay, when angle at the center is 360 degree, that case the area of the sector is phi r square. So must be kept in mind, when degree measures of the angle at the center O is 360, then area of the sector is phi r square. Okay, so when angle at the center is 360 degree, then that case actually entire circle is the area, entire circle is the sector of the circle. Okay, so therefore the area of the circle that is equal to area of the sector. That is why area of the sector in this case is equal to phi r square. Okay, and now so when the degree measure of the angle at the center is 1, then area of the sector is equal to phi r square by 360. Okay, so this is when the degree measure of the angle at the center is 1. Okay, so this must be kept on your mind. Degree of the measure of angle at the center is 360. That case area of the sector is phi square. When the degree measure of the angle at the center is 1, then area of the sector is phi square by 360. Okay, so therefore when the degree measure of the angle at the center is theta, then area of the sector is basically equal to phi r square by 360 into theta. Okay, so this is actually area of the sector when the degree measure of the angle at the center is theta. Okay, so this is the formula for finding the area of the sector. The degree of the measure of the angle at center is theta when. Okay, so thus we obtain the following relation or formula for area of a sector of a circle. Okay, that is area of the sector of angle theta. This is equal to theta by 360 into 5 r square. So this formula is very important formula. Okay, so this formula will use to find area of the sector of angle theta. Okay, so note it down. Okay, and practice and practice. So area of the sector of angle theta, this is equal to theta by 360 into pi r square. So but if we remember this formula, then you can solve solve any problem related to this. But you must be learn what actually concept around this formula. Okay, that will help you in your higher classes. Okay, so that is why how we actually come to this formula that must be kept on your mind. Okay, so this concept will help you in your higher classes. Okay, so area of the sector of angle theta, this is equal to theta by 360 into phi r square, where r is the radius and the radius of the circle, and theta that's angle of the sector in degrees. Okay, so you must be kept in your mind. Theta is basically the angle of the sector in degrees, and r is basically the radius of the circle. Okay, so these two, if you know this the value of theta and r, then you can find area of the sector of angle theta, that is theta by 360 into phi r square. Okay, now a natural question arises: can we find the length of the arc APB? So now natural question arises: can we find the length of the arc APB? Okay, so can we find the length of this arc? So corresponding to this sector, so yes, our answer is yes. We can find the length of the arc APB corresponding to this sector. Okay, so yes, again by applying the unitary method and taking the whole length of the circle as 2 pi r, that we know that the perimeter of the circle, that is the total length of this entire circle, that is equal to 2 pi r, where r is the radius of the circle. Okay, so here we are taking the whole length of the circle of angle 360 degree as 2 pi r. So we can obtain the required length of the arc APB as theta by 360 into 2 pi r. Okay, so the length of an arc of a sector of angle theta, this is equal to theta by 360 into 2 pi r. So now you can find the length of the arc corresponding to this sector APB. This is equal to theta by 360 into 2 pi r. And now let us take the case of the area of the segment APB. Okay, of a circle with center O and radius r. So now you can see this figure. So in this figure here, this is actually a segment. Okay, segment of this circle, and here AB is a chord of this circle. Okay, and we need to find the area of the segment APB of a circle with center O and radius r. Okay, so you can see that area of the segment APB, this is equal to area of the sector OAPB minus area of triangle OAB. Okay, so area of this shaded region is basically equal to area of the sector OAPB minus area of triangle OAB. Okay, and we know the area of sector OAPB. Okay, so that we have studied in our previous slide, and how we can make the formula that we have also studied. Okay, so area of the sector OAPB, this is equal to theta divided by 360 into pi r square. Okay, so area of this sector OAPB is basically equal to theta divided by 360 into pi r square. Okay, so area of the sector OAPB is theta by 360 into pi r square, and area of triangle OAB. So now we need to find the area of this triangle OAB. Okay, so here we need to find the area of this triangle. So how can we find? the area of triangle OAB. So we know the formula for finding the area of the triangle. Okay, so basically we have to use the concept of area of triangle. So now from figure 11.3 and figure 11.4 respectively, you can observe that area of major sector OAQB, this is equal to pi r square minus area of the minor sector OAPB. Okay, so you know the degree measure at center is 360, then the area of the sector is equal to pi r square. Okay, and we have found the area of the minor sector, that is OAPB, is equal to theta by 360 into pi r square. Okay, so now for finding the area of the major sector OAQB, so we can use this formula pi r square minus area of the minor sector OAPB. Okay, and now area of the segment AQB, this is equal to pi r square minus area of the minor segment APB. Okay, so if you know the area of the major sector, then you can if you know the area of the minor sector, then you can easily find the area of the major sector. Okay, and if you know the area of the minor segment, then you can easily find the area of major segment. Okay, so now let us take some examples to understand these concepts. Okay, so now we will take some examples to understand these concepts. Okay, so to understand areas of sector and areas of segment of a circle, here we'll explore some examples, and by that examples we will clear our concepts. Okay, so let us see. So in example 1, here we have to find the area of the sector of a circle with radius 4 cm and of angle 30 degree. Okay, so also find the area of the corresponding major sector, and here we have to use the value of phi is equal to 3.14. Okay, so let us find the area of the sector of a circle with radius 4 cm and angle 30 degree. Okay, so student, we know the formula area of the sector of a circle is equal to theta by 360 into pi r square. Okay, so we can now use this formula and we can easily find the area of the sector of a circle with radius 4 cm and angle 30 degree. Okay, so let us see how to find it. So we have given sector OAPB, that you can see in this figure. So this is our sector OAPB, and we have given this angle is equal to 30 degree. Okay, so and we've also given the radius of this circle is equal to 4 centimeter. Okay, so now area of the sector, this is equal to theta by 360 into pi r square. So now if we put the values of theta and r in this formula, then we'll get this is equal to 30 by 360 into 5 into 4 into 4 centimeter square. Okay, and this is equal to 12.56 by 3 centimeter square, and this is equal to 4.19 centimeter square approximately. Okay, this is not exact value, this is actually approximate value of area of the sector. Okay, so therefore the area of the sector is equal to 4.19 centimeter square. And now area of the corresponding major sector, this is equal to pi r square minus area of the sector OAPB. Okay, and we find the area of the sector OAPB, this is approximately equal to 4.19 centimeter square. Okay, and here area of the corresponding major sector is equal to pi r square minus area of sector OAPB, and this is equal to 3.14 into 16 minus 4.19 centimeter square. Okay, and if we calculate it, then you will get this is equal to 46.05 centimeter square, and this is approximately equal to 46.1 centimeter square. Okay, so the area of the corresponding major sector is equal to 46.1 centimeter square. Okay, so the area of the corresponding major sector is equal to 46.1 centimeter square. So alternatively, we can use the area of the major sector is equal to 360 minus theta by 360 into pi r square, since the angle of the major sector is equal to 360 minus theta degree. Okay, so now we can also use this formula for finding the area of the major sector. Okay, so you can use this formula also. So if you use this formula, then you can also find the area of the corresponding major sector, and that is basically equal to 46.1 centimeter square approximately. Okay, so now here if you use this formula, then you'll get this is equal to 360 minus 30 divided by 360 into 3.14 into 16 centimeter square. Okay, and this is equal to 330 divided by 360 into 3.14 into 16 centimeter square, that is equal to 46.05 centimeter square, and this is approximately equal to 46.1 centimeter square. Okay, now let us see example 2. So here we have to find the area of the segment AYB, that is shown in figure 11.6 if the radius of the circle is 21 centimeter. Okay, and angle AOB, this is equal to 120 degree. Okay, and here use phi is equal to 22 by 7. Okay, so we need to find the area of the segment AYB. So let us solve this problem. So area of the segment AYB, this is actually equal to area of sector, that is equal to YAYB minus area of triangle OAB. Okay, so now area of the sector OAYB, this is equal to 120 by 360 into 22 by 7 into 21 into 21 centimeter square, that is equal to 462 centimeter square. Okay, so area of sector OAYB is equal to 462 centimeter square. And now for finding the area of triangle OAB, so here we can draw a perpendicular line on the side of OAB. Okay, so OM is perpendicular to AB, that is shown in this figure. So note that OA, this is equal to OB. Okay, therefore by right hand side RHS congruence, here this triangle is congruent to this triangle. Okay, so M is the midpoint of this triangle, midpoint of the side AB, and angle AOM is equal to angle BOM, and this is equal to 1 by 2 into 120 degree, that is equal to 60 degree. Okay, so now we can let OM, this is equal to x centimeter. So from this triangle OMA, from this triangle OM by OA, this is equal to cos 60 degree, and this implies x by 21 is equal to 1 by 2, since cos 60 degree is equal to 1 by 2, or x is equal to 21 by 2, so OM is equal to 21 by 2 centimeter. Okay, so now also AM by OA, this is equal to sin 60 degree, that is equal to root 3 by 2, so AM is equal to 21 times root 3 by 2 centimeter, and therefore AB, this is equal to 2 times AM, and this is equal to 2 times 21 root 3 by 2 centimeter, that is equal to 21 times root 3 centimeter. Okay, so area of triangle OAB, this is equal to half times AB times OM, that is equal to half into 21 times root 3 into 21 by 2 centimeter square, that is equal to 441 by 4 times root 3 centimeter square. Okay, so therefore the area of the segment AYB, this is equal to 462 minus 441 divided by 4 times root 3 centimeter square. Okay, and this is equal to 21 by 4 times 88 minus 21 times root 3 centimeter square. Okay, so these are all about this lecture. So I stop here this lecture. Thank you very much to all of you.